Single responsibility principle, or in short SRP. This is a very useful uh, principle, and many of the quality attributes or simply the non-functional requirements are met from the software designing using this principle. This principle states that the design of your classes should be in such a way that it has a single purpose or single responsibility. Or we can say that uh, the design of your class must not have more than one responsibility. If in case where your class has more than one responsibility or purpose, it will not follow the single responsibility principle. Uh, any single object must be made for a specific one function. Example: an account class is responsible for managing current and saving account, but a current account and saving account classes would be responsible for managing current and saving accounts respectively. This means if you design a class in such a way where this particular class manage both accounts, current account and saving account, this means it is not following the SRP, because it has now two responsibilities, one for handling the current account and another for saving account. But if these two different activities, different function purposes of responsibilities are managed by two different specific classes, then we can say it is following the single responsibility principle. There are two things you must remember while following the single responsibility principle. First, your class or method should have only one reason to change. This means if you are bringing some changes in your classes, so there should be one reason. And the second point is that your class or method should have only one responsibility or purpose. Now discuss the advantages. What sort of advantages, benefits we can achieve while designing a software using the SRP. First is improved code readability and maintainability. So SRP assure the code readability. It is easier for designer and developer to understand the structure of code if it is following the SRP, and also it is easier for the maintenance team to bring changes in specific classes designed for a single responsibility. Enhanced modularity. When we talk about the modularity in our previous lectures, that how modularity bring easiness for developer and for designers. So there are certain advantages of modularity, like testing become easier with modularity, managing the software in pairs become easier with modularity, and similarly bug tracing and fixing of errors etc. is also easier with modularity. And one of the important property from modularity we achieve is the reusability, because when the software is decomposed into many modules, the probability of certain modules to be reused in other software or for some other purpose become easier as compared to a single module. So how we achieve modularity, this is a question. So one of the principle which contribute for modularity is the SRP, because we decompose our software into particular classes that is responsible for single responsibility. For example, if we have a one code which comprise of one class or two classes, two or three classes in strong composition that are dealing too many functionalities, as compared to the another scenario where we have designed a particular classes for specific functionality. So that case where we have designed our software using SRP, where we have separate class responsible for specific responsibility, uh, shows the modularity decomposition of software, because at the end we the, at the end it is the or class or two classes that are strongly coupled in composition and are mapped to the components. So if we have too many classes that are dealing many responsibilities, uh, shows these these classes are mapped to several components as compared to few components. So this means SRP assure the modularity. Testing, as I stated early, the testing also become easier with SRP, because classes are now decomposed into several classes where each class has a distinguished responsibility, and the code structure also become reduced. So the code also become reduced and the structure become more understandable, so testing become easier. Complexity is also reduced, so if we bring some change in the code, it will not cause any complexity, or we can say the code is not complex and it become easier to bring changes, and especially during maintenance phase where different team members work on these classes to bring changes. Reusability, because if we go to the modularity and decomposition of classes, so reusability probability also increase, and it also bring improve it also bring increase in the collaboration, and then it become easier for pair developers to collaborate while working on the code. Facilitating refactoring when behavior is neatly encapsulated according to SRP, it becomes easier to refactor code over the time. Changes required for one responsibility would not impact others, reducing the risk of introducing bugs during modifications. Now come to see some examples that are with and without SRP. You can see here we have a class, student class, that is responsible for three different things: student registration, calculation of student results, and sending email. So this means this class is not following the SRP because it has many responsibilities. In this case, this student class has three different responsibilities. Now, as compared to the previous code, if we see this code, we have three different classes designed for a single responsibility. So this means this code follows the SRP. Now you can analyze which code is easier. look to another example. For example, we have a class, invoice class, and we have four methods: add invoice, delete invoice, generate report, and email report. So these are four different responsibilities, and this class is managing and handling four different responsibilities, which means it is not following SRP. But if we move these two methods into a single class and these two to separate classes, this means up to certain level now this code is now following the SRP. So this class is now dealing the two different activities. Still it is not pure the SRP, but it is quite improved, because from one class we have decomposed it and made and converted and refactored the code into three different classes, each with specific responsibility. Now see this example. It is a user data management, and which is following the SRP. You can see here the class user data. The user data class is designed to store and manipulate user information such as name and age, and it has private members variables and public member functions. Okay, so private members are, you can see here, we have private members string name. This stores the name of the users, and integer age. So this store the age of the user. So we have two private data members, the name and the age. And the public methods. So public methods, you know, can be accessed outside the class. So this is the user data method, which is called the constructor, as the name of the class and method is same. So the constructor user data, this constructor initialized the name and age of the user when the object of the user data class is created. So this means when the object of this user data class is created, it will be called automatically. So if we see, we have these two members here. Name, it initialized the name variable using the passed argument, and which is the name here. So we can take any value here. And then age, initialize the age variable using the passed argument here in the age. Void set name. So what does it will do? Void set name, this setter method allows you to update the name of the user. It takes a string argument new name and assign it to the name member variable. Okay, so it will take here and will assign it to the name. Similarly, the get name constant, this getter method return the name of the user. The constant keyword indicates that the method does not modify the object. And similarly, we create the set and get for the age. Now we will see we have another class. So this means this user class is designed specifically for taking the name and age and then show it. So setting and then get. The class user printer. So this class, the user printer, is responsible for printing the user information. This follows the single responsibility principle, meaning that this class is focused solely on displaying the user details, not managing or storing. So this means the roles are now distinguished, specific. The, this class role is to manage the user data, okay, that is by using set and get, and the user printer class, which is responsible for displaying, printing the user information. If we see here the static void method, static method is taken, okay. So static method print user information. This static method takes the user data object as a parameter and print the username and object. So this means this class, this method get take the user data object. So user data object will contain certain information, like the object must have name and age. This method uses the get name and get age methods of user data to access the information and print it in the format. You can see here we have cout name, so this one will appear as such, and it is the user dot get name. So what does the user shows? The user shows the user is the user is a variable, and it is taken for this class object, which means it will contain the information of this user data class, and then certainly certainly the age here, okay. Now this is the main int main, okay. So the main function demonstrate how the classes work. So first thing you should see here, user data, okay, object. So this create a user data object name user with a name John and age of 25. This means when this object is created, this function will be automatically called, okay, because it is a constructor, and it is the specialty of constructor that whenever the object of this class is created, it is automatically called, and this name will come to this variable name, and this age, which is 25, will come here. So after that, you can see here we have user printer. User printer is the this class name, and we can see here this is the print user info method. So we don't need to create the object of this class because it is taken as a static, so we don't need, we just refer it, and we have mentioned it here, the user object. So this means the user object is created for this class, user data class, and this user object is passed here, so it will come to the you can also see here this static method contain the object. Which class object? The user data object, and it will come to this user variable. So we can take here any variable, like we can here take xyz. So we are passing this object, which is user, okay, and it will come to this user variable. And now you can see here user, which contain this user object for this user data class, and dot get name. So what is the name here? Dot get name. Get name contain, it is returning the name, and this name come from here, this John will come to here. Okay, will come here whenever this method is created. Whenever this object is created, constructor is called automatically, and these two parameters, the name and age, come here, and using this get name it is displayed. Now we are updating the user information using the set method. So this user, which is the object created for the class user data, and dot set name. Now this method is called, okay, set name and set age, and this name will come here to this new name variable. You can take any name here like ABCXYZ, and it will come to the name now. So name now change from John Doe to the Jane Doe, and the age is set to the 30. This means it is updated from 25 to 30. And now user printer user info. So this method is called again. So we have this user, and user is the object created for this user data class. So this object will pass here, and when this is called, user will come to this user variable, which can be any variable, and now it is displaying the updated data get name. So get name is called, but now name is changed because it contains now the new name, and these updated information are also printed here. So I have explained each and every line of the code, but the main thing you must understand is what was the purpose of this code. To have understanding on SRP, we have two different classes, and these two classes are interrelated. We need this user data class in user printer class, but the roles are defined separately specifically. So this is strongly following the SRP. Now this code is looking more structured, more easier, more maintainable, and more reusable. And for developers and for maintenance team, it will also become easier for them to bring changes, and also testing of this code is also easier. Now we will compare this code to the this is the same. You can see here the result is same, and the problem is also the same. The main goal is also the same, but what is the difference between this code and the previous code is that this code does not follow SRP. Why? Because we have considered only one class with the name user, which is dealing these two responsibilities. One is the user management, and another is printing the user information. You can see here we have user, and this is the constructor, the same logic. Okay, whenever the object of this class is created, it will be automatically called. We have private data members, we have void print user information, okay, set name and get name. So this is the print user information, which is a method here. As compared to the previous code, we have user printer, we have taken user printer as a separate class, but here user print user information is taken as a method. So if we come here in main, what does it shows? It shows the user. This means user is a class, and we have taken the user object here. So whenever it is created, the constructor will be called, and this information, this data, name and age will come here. Okay, and now what is this? User dot print user information. It manage and print user information in a single method. So this means now this print user information is a method for this class to which this user object belongs, and this method is called name and age is shown. Now for updated user information we have user.setName, user.setAge, and then call this method again. So if you see here, writing of this code is easier as compared to this. Okay, if we compare and deeply analyze it, but the problem is that this code is not the structure of this code is not managed well as compared to the code which follows the SRP. So the probability of reusability is also less as compared to the previous code. Okay, also managing this code in pairs, especially when multiple developers work on this same code, is also difficult. Also this one does not assure the modularity and components. So this means we must have to assign this user to one component. We have to map this user class to a one component rather than two components. Here we can design these two separate components which must assure the reusability and other qualitative attributes which are discussed as a benefits of the SRP. Okay, so this was all about the SRP.